No, I want the current through all the branches. Even if you want polarity of 4 volt, will change later on problem. Huh? But first we'll discuss some basic. Next problem, I'll change it. Okay, this is a circuit. Okay, we'll take this one. Yeah. No, we have to give the polarities. What is the overall method of this? We should define, okay, this anyway, this is 0 volt, R3 is there. So this will be 0. This will be 0. I'll bring with the red color. I think somehow if you can define this, rest all you can manage, no? And the cell is there. What should be the potential difference? 6 volt, 4 volt. Then the potential difference between these two should be 12 volt. We don't know. So you can we write this as like a 12 and this is 0? See, please do think. I just picked up a good problem. Can we write 12 and 0? Because potential difference should be 12. So the other student, what you will write this as 8 and minus 4. If you write this as 8, so I'll begin the problem like this. One student will write like this. Is he right? Sir, you only said potential difference across cells should be 12. So 8 minus of minus 4 will be 12. Okay, then how much of current here will be? 8 by 2, 8 by 3 ampere. Other student, what he did is, he will write like this. Or let him directly take it. 12 is right. So now also potential difference, how much will be 12? Then what is the current here? Will be 4 ampere. They tell me like there is some ambiguity, at least please do learn. So we don't have any formula here. It has to be learned by comparing things. Tell me like which student is correct. I think I'm bringing in front of you the situation. Eight volt. Who is correct? I'm asking one of the best question for you now. Who is correct? Both are correct. How both are correct? How much of current will be here? 4 ampere. How much of current here? 8 by 3 ampere. If I connect emitter, emitter will read on okay, since you are doing experiment for you 4 ampere, other student is doing for him 8 by 3 ampere. No, any emitter connect here has to read same. No, both the students, so when they go in the lab and check it, no, this may not be the reading. Both are wrong here. So this is ambiguous, no? Sir, what about here? So this may be also wrong then in that case. No, this is the sure, no? We are no, this is zero potential out there. So there's no problem with this. Fine. So this definitely there's a question mark. Getting the idea? So therefore, shall I say it's a wrong? Wrong of what? Not question wrong. These potentials are wrong. So what is the correct then? We don't know that. When you don't know what you should do, I put some value V1 and V2, solve it. Hope all of you getting the method. So how to define potentials is what the core idea. I'll put it in corner here. Second, I think this nodal analysis, if you really want to learn, it will come by solving different numericals comparison. So don't suggest. I think yesterday some 4 students, they have sent me message like, sir, like a nodal analysis, tell one suitable method. Tell me where is the suitable method? Problem to problem, things will change, no? And somebody even sent message, sir, any better formula to assume potentials, from where formula I'll bring. I think even you can't expect in science shortcuts of that extent where it will be like watching movie. How we enjoy movie like that, you can't enjoy science. Your head should break up, then only you are learning science. No, okay, this is the I'll begin like this. 6 volt, don't take it under. Parents are calling my kid is under lot of pressure. What's wrong if you're in pressure? Tell me. What will happen? Nothing will happen. No. Yes, definitely. What happens? Setbacks will be there. You'll become strong. No. Definitely. What happens? See, physics class is over. Then what will happen? Your head. You should 10 minutes open. You should close it. Let me relax. Huh? I'm under pressure. I'm stressed. You should face such a situations. Huh? Happily, if you solve physics problem, then there's a question mark. Okay, I'll begin. Let's come to the concept. Let's not waste time. V1, V2. We don't know this. Okay, that has to be calculated. If we know V1, V2, then we can get everything. So, but we know one thing. V1 minus V2 is how much? 12 volt. After this, what to do? Applying KCL. Applying KCL. But sir, we don't know currents. So shall I go for distribution of current? That's what nodal analysis why we are bringing to avoid distribution of current, branch current method. It will take more time. So as a teacher, I should not show current year, current year, current year. Let's assume apply KCL. Then what is use of nodal analysis? Already you distributed current, right? KVL over, no? Why to struggle so much? So therefore, we'll give name for the junctions. This is P, P1, P2 at P1. This is totally, no. So at P1, shall we write here V1 minus V2? We don't have anything near, no? There's no resistance here, no? There's no resistance here. So let me come on this side. V1 minus 4 by 2 plus V1 minus 0 by 3 should be equal to certain current. We don't know that. Let it be I. That current, let it be I. This one now again at P2. At P2, this I will leave. This I is entering, no? So here at P2, it will be V2 minus V6 by 4 plus V2 minus 0 by 1 should be equal to I.
Minus I.
So one thing I'm very sure, what current leaves here, that current should enter here, no?
Minus I should be.
Wait. Let you give your teacher some time. In the end, you can come back. Okay, what current here leaves, that much of current should enter here. Will agree this much? So shall I go for minus I or plus I? See, that's what you have to take help of some slight, see, currents, I'm assuming like this. These two currents are entering and this is leaving. Then what you write? The potential difference. V2, so here it will be like this. V2 minus 6. Okay, we'll do one thing. Current, it is coming. So here it will come like this. So in this case, you write 0 minus V2. Okay, fine. Many are asking me doubt. Okay, I'll do one thing. IA, IB. So what is your equation will be? IA plus IB should be equal to I. At least, okay, fine now. What is IB? 6 minus V2 by 4, 0 minus V2 by 1. This should be equal to I. Or what is I is equal to? V2 minus 6. V2 minus 6 we have to write. No? So V2 minus 6 by 4, V2 minus 0 by 1 should be equal to minus I. Shall I bring minus sign or shall I just keep only plus I? So negative sign has to be brought. you know to, because it has become a practice. So therefore, this ideas like this, we get a situation. In that case, you should be careful enough of this kind. Equate this, solve it, and what is the reference? V1 minus V2 should be 12 volt. Two equations are there. Okay, anybody answer?
V2 minus 78 by 25.
78 by 25. V1?
220.
220?
222 by 25.
Is it 12 volt difference?
Yes, sir.
Yeah. It is not this. It's not there for a syllabus, but numerical